Right now I'm going to talk a little bit about communications environments and hardware-software interface for these. One thing that I'm going to key on in this case is a photon, and we'll look at some of the other ones as well. But let me talk about generalities first. A general concept associated with communications is the following. I'm assuming everybody has had a basic communications course, right? So if I were to say, what is that? You would say that is a antenna. And I'm just going to use a block diagram in this case. Here we have the radio. The radio could be very complex, like what they use in Wi-Fi, what, for example, Qualcomm might use for CDMA, GSM. It is the analog aspect of communicating, how you do it. And we'll just say that it has a lot of stuff in it which is not a part of this class. But there is another part, another aspect that is a part of this class, and that is what we call the baseband processor. And inside this baseband processor is what we will call our RF interface. Now remember, in communications, when we talked about most, I should say digital to RF interface, we had one concern, and that was the physical layer. But there's a lot more associated with communications that you have to worry about. It could be everything from protocol to how data is transferred, even how many wires are actually associated with that radio. Give you a good example is, well, here's a question for you. When you're communicating with a radio, you have to worry about what aspects of the communications. Well, what's the main important one? I don't think anybody, somebody might have said it, but it's the data, right? You have to worry about the data that you send. But with a radio, think about just a regular, average, everyday radio which you're transmitting and receiving. What about distance when you're communicating, right? Some might be really far away, some might be really close. So what do you have to worry about? Well, modulation, but more importantly, energy, right? Because don't forget, radio signals, they degrade at, I believe it's exponential. So if my radio transmitter and receiver are within a meter of each other, do you want to be sending lots of energy to the transmitter? Well, the receiver will probably be blown away. So you also have to worry about power. How much energy are you transmitting? You also have to worry about protocol. So sure, you have a radio and it could transmit at whatever modulation that you have, but we're sending this data. How do we send it? You have to have some control signals because, for example, you might want to address one particular device at the other end. So maybe you have a concern that you want to have specific protocol of how you're doing it, an address of the other device. There's a lot that's included in this, isn't there? The other problem too is that what if your data is really big? Like you want to send 10,000 bytes. Well, most radios can't handle that all at one time. You send a little bit, and then you send another little bit, and you send another little bit. Well, there's a lot of concern of how do you break up your data into manageable pieces. So that just takes a lot of effort, right? Wouldn't it be easy if you could just say, I want to communicate, and here are some of the general things I want to worry about. And so what companies have started to do is they package in everything that you might want to might want to communicate. And you have a line that you send instructions of what you want to happen. These instructions would be, how much power do you want this radio to have? And what address do you want to send this to? And oh, by the way, here's just the data. I just want to send it. And this device here will take care of everything for you, such that in many cases you really don't have to worry about, is this Bluetooth or is this Wi-Fi? You just say, I want to communicate in this certain way, and you might have some setup processes that you need to do. And here's the neat thing. They give you libraries. And these libraries, all you do is you identify, oh yeah, I want to run as a point-to-point network. I just have 2 devices. I'm going to send to another device, the other one's going to send back to me. That's all I worry about. Or maybe it is a Wi-Fi module, and you need to say, all right, go ask somebody out there, I need an IP address. And then it gives one back to you. And then you say, I know what my other IP address is way out there. I want to send this data to that one out there. And in some cases, you don't even have to worry about what your IP address is. All you're doing is you're just saying, here's an IP address, send this data there, and just, if it sends anything back to me, just give it to me. It doesn't even have to know what its own IP address is. All you're worrying about is that you have a data line going in, and you have a data line coming out. So for you, or as we say, all y'all, for your upcoming project, you probably want to treat this communications device as just anything, whether it be Bluetooth, Wi-Fi, any of the Zigbee, anyone sending data out, and I'm going to you do your for your block diagram, you need to know exactly what pins are required for sending out and sending in. And so we're going to spend a little bit of time today looking at all the different types of pins, or the different types of possibilities, and I'm going to have you actually use the computers in here to look up some of that information, and we'll look at that one by one and see what's important, what's not important. All right? So let's take a break. And when you come back in 5 minutes, log into your machines, and we're going to look at certain websites. All right, what we're going to do is we're going to look at 3 different devices. The first one is going to be the particle, the photon. The next one is going to be an XB, specifically 802.15.4, and the last one is going to be the XB Wi-Fi. Now, they're going to use the same process that I kind of alluded to in the first picture, the first drawing, and that is you're going to have pins that will be identified for being able to take some input and output, communications, whatever. But the modules themselves, also, you can access them via various and assorted tools. So let's take a look at the first one. This is the classical XB 802.15.4. This is available on the SparkFun site. First of all, take a look at this module. Do you see a USB port for this? No USB port on this. So what that means is that communications with this is via different types of devices. For example, there is you can use something like this, which has, in this case, a 9-pin D shell. One thing that we have a few of is a USB plug that we plug the Digi devices in. Digi is the name of the company. That we plug these XB devices into, and we're able to program it and set it up. And if you look at the device itself, it has a certain number of pins. Let's take a look at this. Do you see anything associated with communications? All right, right there. UART data out, UART data in, and oh, look at this. They have digital I/O 0, 1, 2, 3, 4, 5, 6, 7, 8. Pulse width modulation out. They have something here. Here's another pulse width modulation. RX signal strength indicator. Signal strength indicator on a single pin. And it's a pulse width modulation output. What do you think that tells you? Signal strength indicator. It might tell you something like, and it's pulse width modulated, which might tell you, hey, if your pulse width modulation signal is very close together, or the frequency increases, maybe if you were to hook up an LED to that, it might actually give you a really bright LED, and if you're far away, it might give you a low-level LED. But you know what? That information is also going to be available through a UART if you ask for it. So what we're going to see here is a situation where you have your entire device, including its antenna, and you're communicating with it via RS-232. We will have already configured the UART on here to work at a particular speed so that when you send your UART information in and get it out, you know exactly what the speed is, number of data bits, number of stop bits, etc. And that'll be in the lab exercises and the information that Sam is going to make available to you at a later date. So what you might want to do here is to do some setup. There will be specific pieces of code available on the net that you can use and put it inside your own program, like maybe on the Renaissance. In fact, we're going to be using the Renaissance for our two communications labs. And with that Renaissance, or with that code, you will write, are you familiar with AT commands? Who is not familiar with AT commands? All right, a couple of you. In the world of communications, this was originally in the old days when we had something called modems. You would send AT commands, usually A followed by T, and sometimes some characters like an asterisk in front and other stuff at the end. And this would be a particular setup instruction. AT-DT, I think I remember, for data terminal ready and stuff like that. But there will be specific things that you will want to do with that to set up that processor. For example, and this will be something that will be later on. I just want to address the hardware aspect of this today. What's the important thing to note? Well, take a look. There's a lot of I/O type of pins on there, aren't there? Things that might be useful for example, programming. So maybe it sounds like you can actually program that device to do something. Because it has digital I/O, analog input. Of course, power and ground is going to be very important, right? So again, this is a complete module for communications via this particular protocol. It even has a classical modem type of signaling, like request to send and clear to send, and reset pin. All sorts of neat stuff on there too, as well as we said, UART in and out. This is 802.15.4, and that's what Zigbee sits on top of. And again, we're going to get more and more and more into this, into the operation of this in a later class. The next one, the XB Wi-Fi module. Well, let's take a look at what we have here. And can you see this okay? Oop. Is that fine, or do I need to expand it? Happy? Do you see any communications pins on this? UART, again, right? And, oh, again, it has analog input. But what other communications does this have on it? Okay, it has the SPI bus, right? Right there at the bottom. The clock, the slave select. Also request to send, and some other control pins up and down. And oh yeah, it also has an RX signal strength indicator and a reset. And it has power supply and ground. Let's see, ground is pin 10, power is 1. Oh, and UART data out and data in. What was this over here? Oh, data out and data in are the same pins. Power supply, ground. Oh, that looks pretty darn familiar. Reset is pin 5, and oh, pin 5 over here is reset as well. The only thing that differs is some of these pins down here are used for the SPI bus instead of just general purpose I/O, analog input, stuff like that. Now let's look at one more, and that was the particle. If you look at this, this actually has quite a bit more of stuff on it because it actually has a really decent processor on it. As you saw, it had a 1 meg flash and a 128 K RAM on it. And so you're going to be able to write a lot more code on here than the other one. And it looks like it has a little bit more functionality. If we look at some of the pins available here, let me get down to the table. And in fact, here it actually goes into, see if I can get this a little bit bigger. It has, wow, 18 digital I/O lines. It has 8 analog lines and 2 analog lines associated with the DAC. SPI bus, I2C, I2S, CAN bus, USB, pulse width modulation. Well, some of them are actually borrowed, like PWM is on D0, D1, etc. And so they're kind of reusing some pins. Well, that's for the processor itself. If you're looking at the actual part here that you might be playing with, notice that it's got, this looks like it would be analog 0 through 5. It only has one DAC output pin. Oh, transmit and receive. I wonder what that's going to be used for. It has a total of 8 digital lines in, of course, power and ground and some other pins as well. So now, by the way, one thing to note is that this is a complete system. So it has the Broadcom chip and the Wi-Fi built into this, a lot of extra stuff put on there. And if you want to, you can just go with the Broadcom chip and have your own input that you need. For example, let's say you have an LCD that needs parallel interface. Well, you might be able to hook it up directly to it if you have enough pins. And just from looking at this, it has some very similar types of organizations associated with this. Man, this says a lot of stuff on it. And as I said, I got it today, so I haven't had a chance to look at it. And this just explains all these pins and what they're going to be used for. And as you remember from the Renesas RX63N, often a pin of a processor will have multiple uses depending on how you set it up. It could be digital I/O, it could be analog I/O. And so how you set it up will determine how it operates. In this case, it looks like the recommended voltage looks to be about 5 volts, but they also have a 3.3 input. So I'm not sure if they allow you to have either a 3.3 or a 5.0, or you need both. I haven't looked into it in great detail. And some other characteristics of this whole thing. Interesting enough, you are going to be free to use any chip that you wish, or any communications device that you wish, and that's part of your design process. We will readily have available many of these things. I probably can buy a couple more of these, no problem, quickly. They have a very good set of tools for you to actually build something out there on the cloud. But so does Digi. So if you were to look at Digi's Digi's tools, they actually have ways for you to the cloud. There you go. You're going to set up different types of environments. And in fact, previously for our class, we had students use the Raspberry Pi, the Raspberry Pi camera, and the Wi-Fi, the Digi Wi-Fi module to actually communicate with the outside world through the Wi-Fi, take a picture, put it on a website. One of the assignments we also did back then is to have you, the requirement was for you to be able to identify myself, Sam, and or neither of us. We're not sure how we're going to do this lab this semester, but it will give you the tools for you to be able to set up a Wi-Fi device and a website somewhere else and allow you to communicate with it. By the way, this photon particle also has tools that you can use to communicate directly to the device from your mobile phone. So now all of you are going to want to look at it, right? So this is the basic concept of communications I want you to realize is out there, that you don't have to start from scratch. You're just going to use tools that exist to quickly prototype. But it would be good if you chose something that was relatively inexpensive. Now there's one last device that we have not identified for your typical system, all right? Oh, actually two of them, right? One of them was the microcontroller, and the other was your display. So what we're going to do is I'm going to give you a 10-minute assignment. I've all asked you to log into the PCs here, and you all did that, right? Or your laptop is fine. So I'm going to give you a 10-minute assignment, and this will be today's quiz. And the assignment is to identify a possible good solution for your display. Now, what was the display requirements that I had? Maybe 2 inches by 3 inches, something that's viewable. There's products like e-ink, there's LCDs, there's electronic paper, there's, oh, what the heck, LEDs too. You never know what's out there. So actually, I give you 15 minutes. You and your team, all 4 of you, sit down together around a PC. Maybe you have 2 PCs and you have one person look at one technology, one look at another one. And I'm going to have you fill out on a sheet of paper your candidate solutions and why you want them. Right. We have gone through our design, and some people had suggestions. Here's some that might have been a little bit high energy. Here's one. I like this. Somebody had some ideas with some e-ink display modules, $25. Might be a little bit pricey. But they also had another e-paper that is available through DigiKey, ultra low power, for $15 in quantities of 1,000. We had some different, this is a good example. Some people, you communicate with it via UART, SPI. There's another one here that you communicate with it via parallel. There's even others that you are, here it is, MPU, parallel interface, and these are relatively low energy, relatively low power. Now that you see this in the recording, you can go grab it later. The other thing I had to discuss is that we've already got, now we've identified the display, I've talked about some communications. Now that's all left is a microcontroller, and this microcontroller often is in the communications module. Well, it could also be in the display module. So what you have to do is you have to think about all of these together for a hardware diagram. And we've talked about in previous classes hardware block diagrams, and I'm just going to go over this really quickly. So in our hardware block diagram, I want you to worry about the following. I want you to worry about the major types of parts and devices that you have, but I also want you to worry about VCC and ground along with your communications. So it might be that your display is going to rely on UART, and so you obviously need from our microcontroller, a transmit and a receive. You may also need from your, and this is your microcontroller. It may be instead, it may be the SPI bus. You need to identify which it will be. And if you chose one that has parallel, of course you have to worry about the parallel lines. You know, we're going to have 8 lines going in that direction and maybe 1 or 2 in the other direction. Going back on our communications, very often what did we see what the device was that we communicated with? It was also UART, right? TX and RX. But we also saw in some examples SPI or I2C as another type of communications interface. So you're going to have to do the following for our next assignment. So today I'm going to be, or you turned in on Moodle your requirements and your project plan, and next week is your initial block diagram including processor selection. I should also say, and an initial selection of which communications devices you are thinking about using and which display devices you're going to think about using. Of course, at the same time, you are also worrying about some of the lab exercises coming up. So now you have some lab exercises and some homework project assignments for you to look at. So I would like you to assess that. I did not really get into great effort identifying processors, but previously we had talked about, you know, what are the benefits of the MSP 430 especially?
Low power.
Very low power, right? As opposed to the Renaissance, even though they claim low power, we've been using a lot of the higher power devices with the RX63N. ARM, is that a low power device? Yeah, not all that much. Arduino, is that low power? Yeah, not quite. What about Raspberry Pi? No, all right? So now it's to the point where you're looking at the scope and size of the microcontroller. Do you need, for your microcontroller, lots of memory?
No.
Not really, no. Do you need lots of speed? Not really. So a lot of this will be depending on what you need to feed your communications and what you need to feed your display. So in the process, you need to select display. You need to select your communications device. That will also help you select, if needed, your microcontroller. What you also should consider at this time is energy, power. You most likely have to run with battery unless you could figure out how to get energy to a device on the other side of a wall. Is that possible? My watch does that. And I think I talked about that, capacitively charged, right? And we've worked on projects, Sam and me and some others, where a vehicle will drive over a pad on the floor of a garage and capacitively charge an electric vehicle. So there are options like that. Maybe you should look at that as well. Power, battery, charging. And so for your next assignment, you need to identify your block diagram, including processor and other component selection. All right? That is all I have. Thank you very much.